Next up, we have someone who brings serious tech chops with a whole lot of personality to match. We have Matthieu, is the Chief Developer Evangelist at Intel RealSense, where he's helping lead the charge in AI robotics and stereo depth technology. As serial entrepreneur, an active developer, Chris has built and sold 5 tech companies in everything from IoT to decentralized supercomputing. And he's no stranger to the stage, frequently speaking at robotics and emerging tech conferences around the world. Today, he's here to talk to us about the robotics renaissance and what's coming next in industrial AI innovation. Please give a very, very warm welcome to Matthieu, and I hope I'm pronouncing his name properly, and his sideshow, Jimmy.
Hey, thank you, Anthony. Yeah, thank you so much. Hey, everybody, how are you today? Yeah, how are you today? There he is. Everyone wave at Jimmy. I think Jimmy needs a round of applause. So Jimmy is from Unitree, and we just absolutely love him. He keeps getting better. Like, he keeps learning how to walk more like a human. He keeps learning new gestures. So I'm just super excited to be here today. I love robotics, and I turn into a kid every time I'm around them, and I lose track of time. So hopefully I can keep this talk going on a decent schedule. And I do want to keep it informal. So if you guys have questions, throw your hands up in the air. Yeah, I'd love to answer questions. I know we only have 30 minutes, and I'd actually rather talk with you than talk about this. But anyhow, my discussion is really going to be about what I've learned at RealSense, Intel RealSense, over the last couple of years, and where I think all of this is going with computer vision. How many people have heard of RealSense? Okay, probably half the group here. Are you using them for like robots? AMRs, humanoids, like Jimmy's got one right there above his blue. They're the vision. They're the human eyes of robotics. So I'm going to talk to you a little bit about some use cases beyond robotics, but I really want to tell you what I've been seeing and what I think is coming next. So this thing is completely wrong. I asked ChatGPT to give me a timeline, and this is kind of what it threw up there, but we've all been talking about machine learning for decades. We've been watching sci-fi movies for decades, and I think it's all starting to come true. It's really exciting about that. But AMRs, autonomous mobile robots, they really started to rise up like around maybe 11 years ago, right here at the beginning. Then collaborative robots, cobots, like working with humans, and they're getting more effective, more interesting working with humans. But really, 2022, just a couple of years ago, this is when we started seeing the humanoids really start coming to market. And can you imagine the engineering involved in one of these guys? A lot of time, a lot of people, a lot of moving parts, and a lot of intelligence. Like Jimmy right here, he can attach to ChatGPT so you can talk to him and give him missions and whatnot. So 2022 was about the time ChatGPT came online as well. So all I'm trying to point out is I think that this is the beginning of the beginning. Like this, everything is iterating faster and faster, and it's getting more and more exciting. You've probably seen, if you've been following RealSense, you've probably seen by now on social media that we are spinning out of Intel. In July will be RealSense Inc., okay? So what that means is Intel has given us a decade plus of support, of patents, over 80 patents. We've got amazing cameras downstairs, sensors, embedded objects. We just launched a new facial authentication device that's won 2 awards at ISC West. So there's a ton of products, ton of innovation, all downstairs for you to see. But why do you need 3D cameras? Why do you need stereo 3D cameras? Most 2D cameras, like in your webcams or whatever, this is what they see. They just see, like if you're looking through a robot at a 2D camera, it's just going to see a blob of an object. What 3D gives you is what the human eye sees. It gives you depth. So if you look at like this image here, blue is close, red is far, and you can see every object in the picture in a depth map. Even more, you've heard of RGB, red, green, blue. That's what a 2D camera does. What a 3D camera does is RGBD. It gives you a depth pixel for every pixel the robot sees. So, like if this was on a screen, I could put a mouse here, and it would say that's 1.2 whatever meters away. So that's how the robot sees. It sees in RGB for object detection, and then it sees in depth. I love you, Jimmy. It sees in depth for like either following a person or avoiding a person, so that they can maneuver in an environment with us. But what gets really interesting is when you got to traverse areas like this. Like there's a lot of people in this space, only several aisles that are free. What oftentimes, when robots have more than one camera, the lasers work in concert with one another. They're projecting their lasers, and they actually help each of the cameras out. And typically, like Jimmy's, I think only got one RealSense camera in today, but they're adding more and more cameras. They're adding like RealSense cameras to the wrist so they can really see and tactically see what they're grabbing. They're adding cameras behind them so that they can see 360 degrees if someone's sneaking up behind them. So all of this stuff, IMUs. Has anyone heard of an IMU? They're inertial measurement units. That's what gives each camera has like a gyroscope, a positioning, and an accelerometer sensor inside of it. So that helps when the robot, so like in a place like this, there's no GPS signals. You can't get them through this concrete. So what happens is the robot, like Jimmy, they see this world like a human sees, and they do something called VSLAM, Visual Simultaneous Localization and Mapping. So what happens is when Jimmy sees like the innovation stage sign right there, he knows where he's at. So he can kind of geo-position himself where he's at, and then move around accordingly, and then in real time avoid obstacles, like Anthony's sitting there on the ground. So what's interesting is when you combine all of that, you basically are simulating what a human sees. You've got two eyes. Try to walk around your house with a patch on your eye or a hand over your eye. It's not very easy. But when you look at the RealSense camera, you got two depth sensors, you have an RGB sensor in the middle, and you have a laser projector that helps him even see in the dark. But more importantly, on the cameras themselves, there's ASICs compute that's doing all the depth in real time. So you're not offloading any of that compute of the vision perception sensors to another computer to slow it down. It's like a human brain, it's reflex. So when it sees something, it can react very, very, very quickly. Thank you, Jimmy. Round of applause for Jimmy. So, I love you, Jimmy. So present and future, like you see these, like I did a walk around the floor here. I was surprised when I did not see a robot with RealSense on it. So that is really cool. Like all the AMRs, AGVs, humanoids, anything that's moving is got a camera. Even the arm pickers have cameras. The depth sensing. There's also use cases where people are doing spatial mapping, like metaverse, digital twin type mapping with the cameras. So they're very effective at that. And you can imagine as Jimmy's walking around, he's also able to build his own digital twin of the space in real time and refer back to it. So that's pretty amazing. And then this item here about AI, advanced AI models, this is the next frontier. Like everything you're seeing today in like object detection with YOLO or OpenVINO or all these models, they're based on 2D. They're based on like a Cyclops, 2D inference. What's next, I think, is the 3D AI that's coming out of cameras like this, stereoscopic AI cameras. So who has like a Ring doorbell or something like that? you probably get a lot of false positives. Like I see raccoons, I see cats that it thinks are humans or whatnot. But you're going to get much fewer false positives with 3D algorithms. And what all that means is safety first. People and robots need to coexist. If you're not seeing that now in your fabs, in your work environments, you will be seeing that very soon. I met a lady earlier that was running a startup around teaching people how to work with robots. But I mean, it should become pretty self-explanatory how they move. Safety. They should be able to stop on a dime, stop in mid movement, or slow down. A lot of the bigger machines. If you stop a bigger machine, it might take it 10 or 20 minutes to start up again. So they have to learn how to either slow down or maneuver around you so that they can stay powered up. So what I think is happening is vision first. I think you're going to see cameras everywhere. We just released a brand new RealSense camera that's only $80. Now this is affordable for everything. This is affordable for makers, for builders, for Raspberry Pi enthusiasts, and then it's also possible to put maybe a dozen of those little cameras around a motorized machine to have it do things. What I think is interesting, Figure AI, the other humanoid robot, they did a great video and a blog post around what happens when you have robots doing chores in the real world. These RealSense cameras, the motion actuators, etc., they can operate 2, 3, 10 times faster, more efficient than humans. You have a question? Do you have a question? Wave, Jimmy. Can you wave to everybody? Make sure they're still awake. Thank you.
Does anybody Chris, did you want to take any questions?
Actually, now is well, hey, let me make one point on this slide, then yes, I would love to. So start thinking about a question. The one point I want to make on this slide is that what Figure AI was trying to point out is that with the perception models, with the accuracy in the RealSense cameras, as well as the robots being able to operate at I dare I say superhuman movement, these humanoids, these AMRs, they're going to be able to outmaneuver humans right now. Like pick and place, they'll be able to grab things 2 times, 3 times, 10 times faster than a human and still stop on a dime and not hurt a human if there is a human walking around. So I think start imagining what that can do to automate your facilities. Okay, there must be a question out there. Yes, you have a question? Hang on, here's a mic.
I was trying to say hi to Jimmy. See what his reaction are. That's why I want to.
Oh, okay. There. Oh, look who's even looking at
This
you.
is Vivi and Jimmy. I love
All right, but does anybody have a quick question? Yes.
How much computer power you need to do the programming and to make like a robot with it?
So if you're in robotics, people understand robots are actually simpler than they look. They're just lots of little tiny moving parts or lots of tiny little WASAPs, etc. The RealSense cameras themselves, they have ASICs that are doing real-time depth, real-time IMU, sensor data, and RGB, but they still need a compute, right? So with the compute, I mean, I play with Raspberry Pis a lot. I'm a hacker, I'm a maker, and I can tell you my Raspberry Pi does not get hot at all with a RealSense camera on it. But what you can do is, depending on your models, you'll need to do like object detection or to send it to create ROS commands. What I did, this was a crazy, I'm so glad you asked, there's a crazy experiment. At Robotics Summit, I gave a talk. I only had 30 minutes like this. Where's stupid? And I brought my laptop up on stage and I had a little tiny AMR that I built with a Raspberry Pi. And I used Cursor AI, and I just prompted it. I said, can you look around the room, find a human, and I made a mistake. He was pointing at the audience, so he said, ding, 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 there's like all these boxes on everyone's faces, but he said, find a human, and then send ROS commands to move the robot to the human and stop when it gets a meter away. Like Cursor AI wrote all of that code. It's running on my Mac, but then it's talking to my Raspberry Pi just for communications and ROS commands to the motor controllers, and the thing worked the first try. It blew my mind, blew the audience mind, because I was thinking, this is either going to be a wonderful presentation or it's going to fail spectacularly. So we ended up playing with other ideas of what to do, but one other thing we tried there, and it also worked, and I think this is crazy when you think about the future of robotics. We attached that robot to an LLM, like Jimmy's got ChatGPT connected to him, and then you can just start talking to the LLM like ChatGPT or Claude, and you can say, I want you to identify Anthony. So now we have a facial recognition camera. It can look around the room and say, okay, there's Anthony. So then it can say, so then you can just give it a mission. You can say, okay, go follow Anthony at maybe 20% velocity, and the LLM, it's watching every frame from like the RealSense stream, and it's going human, 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 Anthony, yes, true or false, and it's sending the ROS the LLM, like the ChatGPT is sending ROS commands, twist commands to the robot, and the robot is following through on a mission without me writing any code. Like, I think that is crazy. Like, that is what's next, I think, in all of this development. Did that answer your question? But it depends on what you're doing, how much compute they actually need to achieve their goals. And I don't think that they'll actually ever have enough compute. Like, I think the more we want them to do, they'll be needing and requiring more and more compute. And you see NVIDIA building clouds of GPUs to assist the robots. I think that's what we'll be seeing.
So should we push pause on questions for a minute and
no,
get back to the slideshow? Because you got some amazing stuff.
I actually only have like use cases, so I mean, I could talk about use cases, but I'd rather answer questions.
All right. Well, you don't have this chance very often to have literally one of the people at the forefront of this technology to ask questions to. The Intel RealSense is incredible, so please ask questions. Like, I'm gonna ask one real quick. Chris, how many times have you failed before you succeeded? Oh, because I see some students in the room and hanging out in the background. I think that's an important question to ask.
I think if you don't fail, you're not thinking big enough, or you're not trying hard enough. So I've had 5 emerging tech companies I've built and sold, so successfully exited. I didn't say in my bio that there was about 100 other attempts and trials that crashed in flames. So yeah, and timing. Like, you can have the best idea, but if the timing's not right, you're not going to be successful. Too early, too late, not right.
What have you found to be the best use case for a humanoid robot? Like, I feel like I can walk over there and just push it over. So what is the best use case today?
Oh, he likes that question. So
not that I would.
But if you've seen all the videos, there's people pushing these things around because they can stumble and they can recover. Tony and I were walking and he was stumbling and Tony just grabbed, he's got a little handle behind it, but he didn't need to. He recovered on his own. But personally, I've seen Terminator, I don't kick these around. I don't push them around. I still say please and thank you, even though Sam Altman says you're burning tokens by saying please and thank you. But I personally would like a couple, 2 or 3 Jimmys around my house. Once they get to the point where they can do laundry, full, bed, sheets, dishes, cooking, that's coming. Like this. So today, you've probably seen the agility robotics right there. It's the one with kind of the grasshopper backwards legs. That thing is lifting 100-pound boxes at Amazon all day long. If you look at how it's designed, it can get right up to the counter because there's no knees in front of it, and the arms even sit on the sides. So if you listen to the way Amazon's talking, they're They're implementing robots, I think, for automation, but their angle is that it's for safety. They've had a number of safety complaints, people getting hurt on the job. These machines don't call in sick. They don't get backaches. You know, they're lifting 100 pounds all day long and get the people to do other more important things other than moving boxes. AMRs, you know, like the motors, I mean, they're moving pallets around. You see a lot of these use cases here. There's tugs that are pulling carts around. They're strong and they're reliable, dependable. You know, Jimmy was talking earlier, Tony was talking earlier that he can attach to LLMs. So I was talking to another gentleman, I was looking for him in the audience. We were talking about baby boomers and healthcare at home. Like, I think this would be amazing when you get to the point where you've got your parents or whatnot that need help around the house, that are maybe even just need companionship and maybe some basic chore duties. I can't wait till every house has one of these. And maybe they'll be leased. Maybe you won't have to pay, you know, the $16,000, $15,000. Maybe you'll just be able to pay $500 a month or something less and have your own helper. Did I answer it right? Yes.
Yeah, so I work in consulting with a lot of clients who have zero robots, zero automation in their manufacturing plants. How would you recommend I can go about showing them how they can use this technology? And maybe if they're not ready to drop the big bucks on a humanoid robot, like what are some more entry-level ways I could show them the potential of this? Because take in mind, like, their technicians have never worked with a robot before. Like, how can I go about bridging that gap?
So the same advice that we give if you're starting a business: start small, and then you land and expand. They say start small, prove that you can demonstrate, you know, building something simple. Maybe it's as simple as an arm. You know, there's a ton of like open source, like ROS powered arms for like $100 or $200. There's a ton of ROS powered AMRs with wheels for $100 or $200. Here's my thing. If you can make something work on these little $200 ROS power toys, you know, they have RealSense in them. I say toys just because they're affordable. They might have a Raspberry Pi. But if you can make something work on that, the $50,000, you know, ATI, like yellow machine over there, is running ROS and RealSense too. So you're, other than the safety, like you got to really nail down the safety so that you don't run someone over. You start small, demonstrate that this is feasible and possible, and then whatever you deploy on that should be scalable to something bigger, more industrial, that solves your problem. And then you get one win, and they'll probably put a whole department around you saying, we need more wins, can you do this for here, can you do that for that? What I also like to do is I like to talk, you know, maybe you've already seen the operations, but I like to find the biggest pain point. Sometimes the biggest pain point is inexpensive. Sometimes it's like, maybe that's the spot where you've got an arm that can do something and maybe reassign 3 people to something else. So I would find the biggest pain point, see if you can start small, make something happen, and then trust they will fund you for something bigger with scale.
We've got time, guys. Yeah, this is awesome.
And I'd rather do this than the rest of this. Yeah.
Hi, Chris.
Hi.
We've been able to have robots with sense and respond control systems for years. The distinction with something like Intel RealSense and other 2D cameras seems to be that you can sense your environment at a distance and move around. And really, the next step seems to be, as you were saying, understanding your environment, being able to move safely, being able to take instructions and move and do those things without question or error or learn as you're going. How far are we from that? What are the steps that we think we need to get there? Like, GPT isn't enough yet.
Right.
LLMs aren't enough yet. They're sort of the parser for what we say and ask, but there seems like there needs to be another step between how do we take the environment we can now see with a 2D stereo camera and interpret that so that there's sort of more knowledge that can take the parsed request and interpret it and do something with it.
That's an excellent question. So the part that's missing today is the understanding of the world. So like when robots today, they do the V-slam, they're basically just using it for an alternative to GPS. So they're using it for where am I, they can do basic object detection for obstacles, what have you. But the layer that's missing, and it's coming, like there's a lot of companies trying to solve just this problem, but it's the understand, so it's physical AI. So the ChatGPT is one thing, but then now if you want to put the ChatGPT into a robot, that's embodiment, right? So this is like physical AI embodiment. So what they need to understand is, even my mission, they need to reason and figure this out, but still with the understanding of the physical world. So when I watch like Jensen talk and I see what they're doing with the simulators, they're trying to say, let's teach this robot through 1,000 hours of simulation in 1 hour. Like use our compute cloud, run this simulation 1,000 times and figure it out. And I have a friend that built a hexapod, like a spider robot, and he did the same thing to teach it how to walk. So I was like, okay, so he didn't have to program anything. The spider learned how to walk, and what I kind of freak out about is like, what if it walks differently than a real spider? It might. They learn how to be more efficient, and Jimmy even learned how to walk better since the last time we saw him. He's constantly learning as well. So I think it's really the understanding of the world and the physics of the world that's coming. So that's another important thing. So I think yeah. So his another good question is like, if you want to tell the robot to sit down, it needs to understand that it needs a chair. So I think with Jimmy, like I think that's possible. But it takes time to teach them all of these. Look, he's going to squat. Make him squat down. That's his chair. He's got a built-in chair. but yeah, so they would need to look around and say, okay, I know what you're asking, and I want to sit down like a human out of the way, or find my charger. I have to go back and jack in so another robot can come out and take my place. Yeah.
So what's next for RealSense in particular? So we have been using these LED cameras for some time, right? So what will be the next step? Is it some software, hardware improvement, sensors? What do you think is needed in that department?
So I'm so thankful you asked that question. That was the point I needed to get out today, and like I said, I start talking about robots and I lose track of time, like the vortex. So RealSense, we launched a brand new product at this show on Monday. We launched a Power over Ethernet IP65 rated sensor camera. So I mean that's perfect for automation like this, where you've got conveyor belts, maybe not necessarily robots, although it would work. But with the Power over Ethernet, you can do 100 meters. 100 meters in distance on that camera. So think of all those use cases: conveyor belts, shopping centers, like looking at people, like real world Google Analytics, etc. That we just launched that on Monday. That's a D555, D555. We have another camera that we launched earlier this year, maybe the end of last year. It's a D457. It's another industrial camera. So that Power Ethernet's an industrial camera. The D457 is a GMSL FACRA connector. So it's got fast MIPI services. It's faster than USB-C, more reliable than USB-C. It's also IP65 for dust and rain, so it can go outdoors. It can see in the dark. But that particular camera can go 50 meters away from a compute source. So we're getting more industrial, more rugged. We're seeing more interesting use cases where these robotics need to go outside. They need to run in low light, and they need to run everywhere. Another thing, most important launch we've had this year was the facial recognition camera. It's called RealSense ID. This thing won 2 awards at ISC West: Best Biometrics Device and Best Mobile Solution. And that thing can recognize your face in 50 milliseconds. So imagine for access control, all these other use cases, ATM machines we're working with, airports, etc. But my excitement is I think Jimmy needs a facial recognition camera either in this camera or above it, because I think that robots need to know who they are allowed to take orders from or requests from. Maybe just me, not y'all. Maybe you can't tell him to sit, only I can tell him to sit. And that's how he would know it's Chris asking him to sit. But then, more importantly, if Chris needs a beer, he needs to know who to bring the beer to. So I think the facial recognition cameras are going to be vital for robotics. But right now we're seeing 1,000 use cases, around the world, like access control and ATMs, etc. Thank you for that question. All right. So we got a minute, half a minute.
I will give one more quick question. Quick. Or I can just give a huge plug to go see Chris at his booth.
It's 8523.
8523.
Downstairs.
Hall E, downstairs. And you will see him, his incredible tech with RealSense. I have this feeling he's got a few of the other cameras down there. You can talk to him about all the use cases that he didn't talk about because we sucked up all of his time talking about kind of the cool things that he's done and all the things that he's doing. Okay, one more very quick question.
And real quick, before you end, one more plug. Jimmy from Unitree. He's got an area right at the main door, and Tony is his daddy. Wave your hand, Tony. Here, you can talk to Tony about Jimmy.
Speaking of the AIs, as you pointed out earlier, so the current majority of the AI is based on the 2D data, but how will it need to be kind of different to take those 3D data in?
So there's a lot of modeling that needs to happen, and a lot of rework on, because like YOLO and those 2D algorithms have evolved over time. But there are tools like Getty that are open source that now do a lot of that training for you. So that's another Intel product that we're working with the Getty team to run more 3D algorithms, to learn 3D algorithms. So I think that's the next fascinating frontier, is 3D AI. Thank you. All right, thank you everybody. Please applaud for Jamie.
Guys, huge round of applause. Huge round of applause.
Wow, thank you all so much.
All right, and I'm going to put in a plug for the next person too. Guys, we have who's next? Gosh, now I just blew my mind. I bet you if I asked Jimmy to remember his name, he would. But honestly, stick around. We have a great speaker next. I'm sorry I don't remember his name. But 15 minutes, you guys can follow Jimmy up front and then make your way back. We are expecting a good crowd. And one last huge round of applause for both Jimmy and Chris. Honestly, thank you so much. Check them out downstairs, Hall E.
Oh,